Hello everyone, welcome to the course Formal Languages and Automata Theory. As we have discussed in the previous lecture about the string containing a, continue to with that we are going to discuss about ending with a. Construct a DFA which accepts a string over sigma equal to a comma b where each string ends with a. First we have seen starting with E, then containing E, then now we are going to see ends with E. The first thing you need to do, we need to write the language. L equal to A, AA, BA, AAA, ABA. And whether is it a finite or infinite language? It is an infinite language. And if it is a finite language, it is sure that we can able to draw a DFA. But if it is of infinite, we can able to draw a DFA or not, we need to check. Okay. Now, to draw a DFA for this, we need to take the minimal string. Represent the structure by taking the minimal string. Q0 is the initial state. By seeing A, it is going to reach the final state. This is the final state, right? Now, how we have reached the final state? By seeing A at the end. Okay. Now, is this a DFA? No. Why? Because we need to represent all the input symbols for the given states. That's why it is not a DFA. Now, if I am going to see B, suppose you consider B you find at the starting and you may get A. You may get A at the end. You may have any number of B's. After this, you may get A. And you need to wait until you get A. That's why what we are going to do, we are going to accept B here. Right? What is the string it is going to take? B, A. If I am going to get at the starting B, then I am going to accept it. I will be waiting for A. If I am going to get A, and then I am going to reach the final state. Why means A is there at the end of this string, that will be accepted and I am going to reach the final state. This is one condition. Now for Q0 we got B and A. Now coming to Q1. If I am going to get A, suppose I am in the state like this, BA. If I am going to get one more A or any number of A's, this represents at the end you will be finding A. That means I am going to accept any number of A's in this state, right? I can have any number of A's. At the end, I am going to find A only. That's why I am going to accept it. Next, coming to the next input symbol, Q1 on B. Q1 on B, where I need to represent this state. Suppose I find B at the starting and by seeing A, I have reached the final state. After this, if I am going to get B, is it the string will be accepted? No. Why means this after this B, it has to wait until you need to get A at the end. That's why you are going to wait until you need to get A at the end. Now what we need to do? We are going to go back and represent the input symbol to the Q0. Now if you observe, suppose I have my input as BA, BA. Is this string accepted by the Finite automata S. Y means the end of the string is A. That's why if I am going to take B, B is the input, Q naught on B, it is going to be in the same state. Q naught on A, it reaches the final state. Q1 on B, it goes to Q naught state, and Q naught on A, it comes to again Q1 state. Like this way, if I have, then the string will be accepted. In this way, we need to draw a DFA. Now, in the same way, we need to check for string acceptance and string rejectance for the given language. Now, your string is ABE. You need to start with the initial state Q naught. Q naught on A. Q naught on A. You are moving to Q1. Then Q1 on B. You are moving to Q naught. Then Q naught on A again, you are moving to Q1. And here Q1 is the final state. That's why the string is going to be accepted. Coming to the rejection. Q naught is the initial state. Q naught on B, you will be in the same state. Q naught on A, you will be moving to the final state, that is Q1. And Q1 on B will be in Q naught state. And here Q naught is not representing the final state. So the string is going to be rejected. The diagram will be represented like this. Thank you. Thank you for listening.